Hello, let's finish up with 13.3 part 2. Complement, the idea of a complement. The probability of the complement of an event E is 1 minus the probability of event E. So the probability that it is not E, we just do like 100% minus the probability of it being E. So if I had the probability of rolling a 5 on a die, it would be 1/6 of a chance. The probability of it not being a 5, like this, would be 1 minus the probability of it happening. So I'd have 1 minus 1/6. The probability of rolling not a 5 would be 5/6. Together we should have the probability of the event and the probability of not the event adding up to be a total of 1, because either it is or it is not. So let's use this idea when we're playing Battleship. And let's say at the start of the Battleship game, we want to find out what's the probability that the first guess that we make will be a miss. Well, that's a lot of areas to calculate how many would be misses. There's a quicker way. If we come about it using this idea of a complement, we can get our answer much quicker. So the probability of a miss is going to be 1 minus the probability of hitting it. Well, I quickly looked up on the internet and saw how many holes each ship had when you're playing Battleship, and it turns out that the destroyer is 2, cruiser 3, sub 3, battleship's 4, and the carrier is 5. If we total all that up, we come up with 17 holes that would be hits. So if I have a 10 by 10 grid, there are 100 holes on that grid, correct? So my probability of getting a hit would be 17 out of 100. 17 would hit ships. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 possibilities of striking it. And I'd have 1 minus 17 100ths, which would be like 100 100ths minus 17 100ths, coming in with 83 out of 100. The probability of a miss would be 83 100ths. Each student receives a 5-digit locker combination. What's the probability of receiving a combination with all odd digits? So step 1, let's just determine whether the code is a permutation or a combination. Well, that always comes back to this basic question. Does order matter? Well, absolutely. When you're doing a lock that's a combination lock, it actually is a permutation, because yes, order does matter. I have to put that combination in exactly in the order that the numbers are supposed to be. So how many different outcomes are in our sample space? There are 10 digits when I'm going 0 through 9. So I'd have 10 times 10 times 10, or 10 raised to the 5th. That's the total number of different combinations possible. The number of favorable outcomes, well, now I need to just play with the odd numbers. Oops, I missed 7. There are 5 of those. So I'd have 5 possibility of odd numbers, 5 odd numbers, 5, 5, 5 for each of those 5-digit codes, which would make me 5 to the 5th. And then find the probability. And we know probability is the probability of successes to the total. And the number of outcomes that we have that are favorable are 5 to the 5th, and the probability would be 5 to the 5th out of 10 to the 5th. This one, maybe we should just say successes here. I think that would be more accurate. So I have 5 to the 5th successes divided by 10 to the 5th possibilities, and that would give us our overall probability. And finally, one of our last problems. Sometimes when computing odds, you must find the sample space first. This can involve using permutations or combinations, because that will help us figure out how many ways something can happen. In this example, 8 boys, 11 girls have grades high enough to qualify for the school's 4 scholarships. If the recipients chosen at random, what are the odds that 2 will be boys and 2 will be girls? So first thing we're going to do is just determine the total number of possible groups in each category. So how many different 2 male groups can I make? Well, remember there was a total of 8 boys, so that's going to give me 8, and I want to select 2 boys out of those 8. Choose to use combinations because we're talking about groups. Groups will imply combinations. So if we do an 8 choosing 2, there are 28 ways to get 2 males out of 8. And then for girls, we've got 11 total girls, and we want to select 2 from those 11. And if I do a combination of 2 out of 11, I come up with 55 different groups of that. So if I go back to that basic counting principle, the number of ways times the number of ways will give us the total amount of ways that something can happen. So we could go 28 times 55, and if I do the math on that, it comes up to 1,540 various ways of getting 2 boys, 2 girls into a group of 4s. What if I didn't care if they were boys or girls and we just looked at how many different ways can I choose 4 member groups? I would add the 8 plus the 11, the boys and the girls, for a grand total of 19. So now I'm selecting 4 kids out of the 19. A combination of 19 choosing 4 gives us 3,876 different ways that we could select those groups. I could go through the probability of successes and the probability of failures, but I think in order to do these odds, I'm going to take maybe just a different approach. And let's just look at the probability of success, or the total number of successes to the total failures. I know that all of these groups with 2 males, 2 females, those would be considered successes. So 1,540 ways for successfully selecting 2 and 2. And then there were 3,876 total 4-member groups. So if I subtract off the 1,540 of successful ones, it'll leave me with the failures, or groups that are not 2 boys and 2 girls. By doing that subtraction, I come up with 2,336 groups that are not successful. So we'd have 1,540 compared to 2,336 failure groups. And if you reduce that down, 385 to 584, that's the odds. Finally, last question, getting back to odds. If I know the probability of being accepted at a state university is 4/5, what are the odds of being accepted? So the odds of acceptance. 4 ways that they are accepted then. 1 way of not being accepted for that grand total of 5. So it's a 4 to 1 odds. That should about do it.